Hello everyone again to my YouTube channel. In this tutorial of PyTorch, today in this session I will show you how you can implement a model using PyTorch tool. Well, here all the packages I need, I import all the packages I need for this session. I will with MATLAB Live and Torch, and from Torch I import this no network, as in no network contains all PyTorch building blocks for no network. Well, so here um, in machine learning, so the first phase or the first part or the first step in any project of machine learning is to prepare and loading the data. So by the way, in machine learning, the data can be almost anything can be imagined. Can be a table of numbers, can be images of any kind, can be videos from YouTube, of course, can be audio files, look like song or podcast, can be protein structures like DNA. So can it be text? Can it be anything? Okay, this is the advantage in machine learning. Can be the data can be anything we imagine because as we know all we are in the age of big data. We have data anywhere. We can extract the data anywhere. We can convert and extract the information anywhere. So for the reason machine learning it's coming, especially deep learning work, we need a huge of data to be work with. Well, in our case here, we don't have a data prepared before, but I will prepare my own data. Okay, we will use in this case linear regression to create data with known parameters. Okay, and then we will use a PyTorch to see if we can build in a model to estimate the parameters using gradient descent method, gradient descent algorithm. Well, as we see here in this cell, I will create a model, small model, of course, based on two parameters here. We have weight and we have base. So y equal to y times x plus y is here, as we know. As we see here, we starting or we initialized our parameters with a random values. We have in this weight, we start with 0.7 and base with 0.3. And we will create in data starting from 0 and ending with 1, and the step is 0.01. So with helping of this action of arrange, we will input all these variable I have here inside of this arrange function. Then I will squeeze it to make it in one dimension. So well, if I run it, this is the result I'm taking now. So this is the result here. This is all the data default here. I create my own data. Okay. Well, the second phase is to split data. Okay. Well, as we know, so here in this scenario, of course, or in this data, we have small data, but in the real world data, uh, before trying to split in the data, we need to clean it. We kind of facing some missing data. We kind of have string values. We need to convert it to a number. I will create a session about this kind of data and how we can work with. Because as we know, in machine learning, the algorithms and models is not understand cannot be understand the string values. So we should convert it to a numbers. Okay. Well, after a phase, exploratory data analysis, we have an important phase because we cannot give all the data we have for a model because in the second phase we need to test the accuracy or to measure the performance of our model. To do this, we have important phase. That's what's called the split in the data. So we can split in data with three parts. So the first part is training dataset. The training dataset is around 16 to 18% of all the data you have is just for training. Because in this training phase, we give the ability for our model to understand the pattern and to understand the relationship between the features and the labels. Okay. And the second part in displaying the data is the training data. So around 20% of data or the rate of the data is for training or for testing the model, to testing accuracy to predict the model and see the measure, okay, all the accuracies on to see the performance, the model and all that. And we have the third one, it's validation and is optional. Validation data set when we are splicing the data to training and the rest of data we are divided into for training and validation data set. So in real world projects, so it's better to have separation at first time in data set. I will show you again in Kaggle, for example, as a platform for competition in machine learning and data science projects. I will show you some real data set we have. It will be always will be separated test data and training data from source. The data is separated from source to data for training and data for testing. So here in our case, I try to build in the same logic here. I try to build in the training split and this testing data. Well, here as we see at the first time, we have training equal to split equal to integer a 0.8 times length of x. That means 80% of all the data just for training as we see here. Okay, this is the logic behind this syntax. We have x prime and y prime equal to prime split. Prime split does mean 80% of data just for training. The same thing for label here. Okay, y it's for training. So here for our testing, we have x test and y test equal to train split to the rest, starting from the 80 index to and is just for testing. After I run this, I will get the result. So we have 80 points just for training, 80 point for training, and we have also here 8 point label, and we have 20 for testing, 20 labels also for testing. We have four split data here. So we have this data and each labels and test and training data with his own label. Here, what I do, I try to build in a function for plotting the predictions. I give as a parameters 5 variables here. We have a train data, I pass xtrain or xtrain here as before. We have xtrain. So this is the data with I split before, and also we have train labels. It's for labels training. Is 8%, and also we have test data. I passed x test, okay, and for labels also I passed this 20 here. Okay, this is all the values I get here. I passed in this function for visualization. Well, also I add in one parameters called the predictions. I call it predictions, and I assign this value of none because it's not ready yet to predict it. Well, inside of this body of function, we have the figure. We need to increase the size of our figure. Okay, and here I want to scatter the points. Here the plot, the PLT scatter. I want to draw this point as a scatter. Is a train data, train labels with this color blue. Give samples 5, and we have label here is calling the training. So the same thing has happened with this data. I scatter this data with this color of green. We simple form. Okay? And we have the label of this skater. So for here, if prediction is not, because it's not ready yet, because it if before I assign it with this non-value, because it's not ready yet to predict. So if we don't, if we predict before, after, if we making or building this prediction, I should pass it here for this function to predict this value as a read points here. Okay, and also for legend, I incorrect the side of legend. Well, if I run it, so this is the result what I get here. Show you here what is the idea behind. I call of course this function of plot prediction. This is the idea behind it. We have a straight line because we're working with the regression analysis. We have this straight line with a dot point. So this blue point here is a test, and the green point here is a testing. We have training for the blue points, training, and the green here is for testing. Okay, so here let's continue. The second phase here, the second phase is the building a model. Well, what I try to do here, I am building a class for linear regression. I call in this non-network model. So everything is here with a non-network model is everything in PyTorch is in non-network model. I create a definition or the initiate function here is just for a variable, so like a constructor. Okay. Well, I call all the functions or all the values or all the variables we have here super. Okay, because I inherited from this model of non-network model. For this reason, I call all the variable we have here. Okay, to initiate variables here. So our model here, as I did before, is simple. We have weights time x plus y is just uh, two parameters. Well, I create here these parameters. We have self weights equal to non-network parameter. Torch dot random because we start with the random values here one, and data type is torch dot float. As we know, the torch is over everything. It's with a float. We discussed that before in the last sessions in PyTorch. And here we requires grad equal true. That means I activated the gradient distance. Okay, I activate the gradient distance method algorithms. I discussed also with that in last sessions when I tried to explain for you the linear regression. Well, this sometimes happen with bias. We have the first bias here. We have self bias equal to no network parameter, third random, and also we started with random values here. Okay, so for this reason we put one here and data type I convert this data type to float. Every time also is with the float 32, especially in PyTorch, and also here I activate the gradient descent. Okay, well, the second step here in this class is to apply this forward function. Forward function here I built it just because we try to send the values to our non-network. This is what called forward. X here is considered as input. Okay, that means the values for X is will be sent it for this model. This is what we call forward. Okay, and we want to return self weights times X plus self bias, and this is the result. What we want here is to return this equation, this model of regression analysis. Okay, this is the content of this class of linear regression. This is what I built here. When we start, so here what I do, I apply here torch manual state 42. It's like a random state because why we do that and assign it with a random values here is because when we run and we run again the model, we need to capture the same values. because we're working with the random values. For this reason, we need to capture and save the same values we have. For this reason, we pass this model set and with the values. Well, here what I do, I create one instance from this class. Okay, we have linear regression model. So linear this is our linear regression here. As a class, we need to initiate or creating an instance from this class. Okay, so model one equal to linear regression. I discussed that before in Python playlist. If everyone is interested to knowing about the POO programming oriented objects, I have playlist of Python. Of course, I discuss that deeply. Well, I create an instance here, and I will check the parameters for my model. Okay, so this is the parameter for my model. Okay, well, this is parameter for my model. So for weights we have these values, and for baggies we have this value. Well, now I will make these parameters in a list. Okay, state dictionary. Well, we run it and to see the values we have here. So the values for weights it's 0.33, and for baggies is 0.1 or 0.12. Okay, so this is the values we have in this model. Okay, this is values for this model. We start from base or we start from random values, but when we implement this model, this is all the result we get here. Okay, so this is the result that we got here. Here in this syntax, so with torch.inference mode, y predict equal to model one, we predict x test. So here we predict, we making a prediction based on this data. This is syntax we work with in PyTorch. So inference mode, y predict as a variable equal to model. We want to predict this x test, okay? That means 20% of the rest of data we want to predict it with a model. At this time, we want to measure and see what's happened. So in Python, this is the syntax to make a prediction. Also, we have in old version we can use no-grad, but the first one, inference mode, is most faster. Okay. Well, here what I we check the production. Okay, we check the prediction here. So this is the value we predicted by my model. This is the number of samples. Here we have 20 samples. We have also 20 prediction. Okay. Well, this is the result here. We have 20 samples for testing and 20 predictions, and we have the value here stored in this tensor. Well, let's continue. Here, what they do, if we see the difference between that, here I call in again this function plot predictions, but in this prediction variable, I make this predict because we predict now. Okay, we making our prediction here. We see. So based on this syntax, we created this variable. This is our prediction or forecast. Okay, I forecast these values. Well, I call this function for visualization. This is my function here. So in non values, I assign my y predicts, my y predicts. Okay, because the prediction is ready now to visualize it. Well, for the reason I call my function here to visualize it. And this is the result I take it here. In this straight line, we have the training test. When training and test values, we have the training here with green or with the blue points, and test with a green one. But my prediction is here with a red point. Well, what's happened? The prediction is really bad. Why we do that? Because we are not make my model to train in my data. So this is why this prediction is bad. So here we need to measure the distance between this point to this point, the all this point, red point to green point, because what we do, we predict this using model, using this sample of data. I try to make a prediction, and you see the distance between these red points and the green point is very far. The algorithm needs to make this distance short and decrease the distance between these red points and green points. Well, this is the difference we get before. So we have whitest and white breeds. The difference between whitest and white labels, the difference between labels between the results. Okay, well here it's in this answer. We have whitest and white breeds. The difference are all okay. Here, this difference between okay this duration is between this point, for example, and this point to this point. This point, all the points with red color and green color. This difference is far. All the distance is far. Well, this the third phase is to train the model because we don't train the model for this reason. We have this bad prediction. Well, what I will do now is to activate or to build in my loss function. So I discussed before in this loss function. So in this example, we have my mean absolute error. That means I use these loss functions to minimize the distance. This is the rule for a loss function. I try to minimize this distance. Also, I create an optimizer here, torch.optim.scgd, stochastic gradient descent. This is the algorithm behind. By parameters, I pass the model with parameters of width and bias here in this attribute. Then I make a value for LR. That means learn rate. Learn rate. That means step I need to update my values. I will add in the length of linear regression or regression analysis. I talked before in these tricks and all these functions here. This is learn rate equal to 0.01 because in optimizer I need some steps. I do not need to make it randomly. I need to specify the learn rate. We have a lot different of learn rate. One of them is other optimizer. We have the steps that I need to update my values. Okay. Well, here I call again these manual seeds to conserve the same values. Here in non-work we have epoch. Epoch does mean how times my model is passed in this data to minimize the errors using the loss action or mean absolute error. Here I choose randomly 100 epoch because our data is small. But when we facing huge data, that means we need to increase the number of epoch. Okay. Here also I created three lists or three empty lists. We have train loss values and we have test loss values and we have epoch count. We need to count in the number of epoch. Also here I using a loop. Okay, I use loop here in the epoch. So for epoch in a range of epoch, we have here 100. Well, I make a model in a training mode. Okay, I will train the model. So based on this epoch, I need to train our model. That means to give for my model all this data here and checking and calculating the loss function and see the error and back again. That's what's called back propagation. We have forward propagation when we send the data as an input with epoch, of course, and calculating the error on all these things, and we return again with back propagation. So in this first phase here we have we make our model in training mode. Okay. Here we the data as using forward. That's what I did for you. My page is equal to model one. It's the version of my model one extrain. That means I put or I send my data as an input at the first time. This is the forward. I send my data to my model. Okay, this is what prediction. So here I calculate the loss function. So when I send the data here, I want to calculate the loss. I want to calculate the difference as here, as we see here in this function. So when I send my data to my model, I need to calculate this, the difference between this green one and the red one. And the goal is to minimizing this distance. Okay, so I calculated the loss here for y breaks and y3. Also, this phase of zero grad of the optimizer, because when we send the data, we calculate in this loss function and all these things, we save it and we make it a zero again. This new approach to come in and to calculate again all these this process or these steps we need to making this comparison between all these approach we have. Here, as I said before, we have loss backward, because here when we send the data, we the calculate the loss function, we predict, we measure the difference, the error we have, we return to updating the data based on optimizer and step. How much or how many we need to minimize or to update my data. So for this reason, we make it in this backward here. And optimizer step is a learner rate. That means what is the step I need to update this model. If we are making this optimizer as a random, that's very hard to find this global meaning. Here, after all these steps, we make our model in evaluation. That's mean we need to make this model ready for prediction. So here we make it in evaluation. Well, we predict again with this syntax with a torch.inference mode. I will to predict test spreads model one. I need to predict this X test. This prediction I need to make this prediction as a X test data. Well, we're calculating the loss for test data also. We have test loss equal to loss function. Okay, difference between predicted and y test, and I make this as a float 32 by default. As we know, all answers in PyTorch is with 30. It's a float 32. So for this reason, I apply this y test just for a float. Here we calculating the difference between the predicted value and test. So here we pass the process of epoch. Here, if epoch equal to 0, if the rest of division equal to 0, here because after each 10 poch give me the results. That is what's the mean in this piece of code. So here epoch counted append, we need to append or put in our list empty. That's what I created before. Put this epoch. And also for train loss values, I try to append this stitch or loss for test or for training. We make all this value for our loss function in inside of this list of trail loss values, and also for test loss values I create an empty list and I try to input all the lost we have here. This loss, I input all this lost or values here inside of this empty. Well, here I want to print the epoch we have, print the loss function for doing the loss function for test. Well, here this is the result. So for epoch 0, for epoch 0, we have mean absolute error here is 0.31 for training, and for for testing. So for testing we have 0.48, and after 10 epoch we have the main here for testing we have 0.90, and we have for testing 0.34. So here we see this error is increased. After each 10 epoch, the error is decreased. That's what we found here. And also for test, okay, we have this value is increased. Okay, so after sorry, so here we apply. So in each team, each team epoch, we measure the loss function for twin and test, and this is the result what I get here. We look here, we have the loss function is increasing with time. After each 10 epoch, the loss function is decreased also for test and twin. Well, here what we look, we visualize in this loss values. Okay, so here this is what we see here in this visualization. We have epoch here and we have loss function for twin lost and test. Okay, for twin loss here we have the loss function here at this level. We add in for after 10 epoch we have here, after 10 other epoch we have in here. That means when number of epoch increase, the loss function decrease both for test and twin lost. Okay, that means the error is minimized when we increase the number of epoch, and that's what's happening. Well, now I find our model learned parameters. So the model learned does mean I will to run state dictionary or the parameters of my model with bias and weights here. After I run it, and also we compare it to original one, because as I tell before here, so sorry, so we have the original values here. At start time, we are starting with the random values here 0.7 and 0.3. Then the result we found after training the model is for weights 0.57, and for attention for our bias we have 0.35. The original one, this is here. Well, now what we do or what we can do is to make a prediction. Now after my model is trained, I will make my model in evaluation mode to predict. Well, with torch inference mode, I want to prediction, making a new prediction. Y press equal to model 1 x test. I want to predict this x test. So this is the result here. this is what I get after prediction. Okay, see the new values here. Oh well, this is so when making the new prediction here, I I call again this function plot prediction to visualize my prediction, and this is the result what I get here. After I train it my model, I make this distance between red points and green points is more short. Compare the first time when I predict my model without any trend or without trying to make my model the ability to build it or discover the pattern between the data. Okay, see the result what I get. So let's show you when predict or when making a prediction. So without train the model, see the result that I get here. So let me show you. So see the result. So before trying to make my model in a training mode, this is the result what I get. The distance between green point and the red point is very far. After training my model, after implement sorry the loss function and optimizer and make it in forward and back forward. So this is the result here. So the error or the distance between green points and the red point is more short than before. Why? Because we're making the model train it before make prediction. Okay. So here I will stop my tutorial. In the next section, I will show you how we can save in my model. Because now my model is ready for prediction. When a new input is coming anywhere, this format of data, we can apply our model to make the prediction. So for this reason, I will show you how we can save in my model and make it for me to use it in the future. Okay. So thank you for everyone again, and happy learning. See you. Bye bye.